You ready to get started?
We are ready.
So good morning, everyone. My name is Pierre Laframbois, and I'm Director of Business Analytics for Covenant Technology Partners. And we're here today to talk about artificial intelligence and manufacturing. Let's go. So we have a kind of a quick agenda this morning. It's not a very long presentation because we have some room at the end for question and answer. But we're going to start off with a bit of an introduction and kind of walk through what we mean when we're talking about AI and just kind of frame all of that. Then we're going to go into a little bit of trends and so forth with AI and machine learning specifically in the manufacturing space, discuss some of the, drivers for this and some of the challenges that the manufacturing industries are having around adopting artificial intelligence in their processes. But then I'm going to go into a couple case study briefs to look at some specific examples of organizations that are utilizing AI and getting some good benefits out of it. And then we'll kind of close out with a little brief discussion of things that you should consider when looking at AI for your specific organization. And again, we will do some question and answer at the end. And so if you do have any questions, please queue them up. First, it's pretty important that we kind of frame what we mean by artificial intelligence. Like a lot of kind of buzzwords that float around the technical industry, it gets mangled a little bit in terms of what it is, and it becomes a little bit of an umbrella term for a lot of different sets of technologies and so forth. But when we're talking about artificial intelligence in this sense, we're really talking about kind of these three things. It's the machine's ability, machine being a computer's ability, to recognize patterns. And those patterns could be in sounds, images, words, that sort of thing. And pattern recognition is an enormous part of the machine learning algorithms that are underneath artificial intelligence. It is what allows these AI systems to ultimately identify whatever kind of business rules you're putting around it and then act upon them. But that kind of leads into the second point. We're also talking about the machine's ability to kind of infer from this data, right? They need to be able to learn and reason across the data. So not just recognize that there's a pattern here, but that pattern equals a certain outcome. So just a really brief example, something that is fairly common in a manufacturing space is looking at predictive maintenance around equipment. And so an artificial intelligence that is trying to perform those type of duties needs to be able to recognize the various patterns that are leading to that failure event. But then again, not just be able to recognize that pattern, but to be able to learn from those patterns of past performance to actually then do something. That could be very simple. It might just be alerting. It might be it actually changes some parameters in the operating of that machinery so that it gets better longevity. It's a lot of things they can do. But in general, again, when we're talking about AI here, we're talking about the set of technologies that do enable computers to understand and interact. And this more naturally and responsively is also a pretty important part of it. And it's kind of, in a way, the distinction between what artificial intelligence is versus, let's say, more of a machine learning. Machine learning tends to fall into these kind of top areas more, where it's more about that pattern recognition and that ability to do something about the data. Where the AI component comes in, it's that ability to actually interact a little more naturally. So, a common example might be a chatbot, where it's able to understand natural language and respond back in natural language. And again, there isn't necessarily a clean, hard line between machine learning and artificial intelligence. Probably the best way of putting it is artificial intelligence is putting machine learning into kind of operation. It's also, I guess, important to understand what artificial intelligence isn't. We're not necessarily talking about something that's sci-fi here, where you have, computers and machines that can have, cognitive type of conversations with you. Talking about mostly simple algorithms, but that are able to act across amounts of data that are just not feasible for a human being. And humans are very good at finding patterns and things, for instance, but we're not necessarily very good in finding patterns across terabytes of data. It's just too overwhelming. Or to look across hundreds, if not thousands, of different attributes for those patterns. And computers are very, very good at that. So AI isn't necessarily new. AI and machine learning technologies have been around for a very long time. But in a lot of cases, they haven't necessarily been applied to practical applications. That's kind of the new portion of this. It's also being driven by a few different things. We have listed here massive computing power. This is mostly in regards to the cloud, where we have global scale kind of computing efforts that allows the ability for some of these machine learning algorithms to be applied in very, very large situations. So as I previously mentioned, that kind of ability to iterate across terabytes of data or more to find these patterns. That is difficult to do if you're just running this off of, a local server or something along those lines. Data is also probably the number one key to any AI system. And we'll talk about that a little bit later, but in general, the availability of these kind of massive data sets is driving this as well. And then lastly, it's some breakthroughs in these algorithms helped improve kind of the methodology here in the last decade or so. So how do we help? How does Covenant help? This is another kind of important framing, topic here. We are not data scientists. We're not out there writing the algorithms for these machine learning and AI systems. Instead, we tend to work with our clients to help architect out these AI solutions. So we look at your situation, your business case, and try to figure out what is the best application for AI in these situations. Further, we're very good at building kind of the foundational aspects. So I mentioned data just a moment ago. Well, data is, again, by far the number one thing that needs to be aligned in order for AI to be successful. And so we spend a lot of our time building kind of these foundational solutions that are used to drive downstream AI processes. And this is ultimately just an extension of the data analytics work that my team typically does. So it's taking things like a data warehouse or traditional analytics to kind of that next level where it isn't just reactive anymore. It's now proactive and prescriptive with AI on top of it actually looking for these patterns and finding them before the things happen. But ultimately, our job is to kind of advise clients on direction and program development around artificial intelligence and data analytics to help improve their overall maturity. And we'll be talking a little bit about maturity as well, because that's another important aspect when we're talking about artificial intelligence. The final thing for kind of introduction purposes is this AI applications, whether we're talking about manufacturing or any industry, tends to be pretty personal to that organization. It's different for everyone. And I've said this already multiple times, but it's kind of to reiterate it. It is only as good as the data that you're feeding into it. It's that classic, paradigm of garbage in, garbage out type of thing. And every organization's at a different level of maturity when it comes to their data quality, the governance around the data, the amounts of data that they're collecting, the importance they put around the data. Do they see data as a valuable asset of the organization, or is it just a byproduct of what they do every day? Those type of maturity questions are essential to being able to have kind of this a successful AI program, but it's also the key to understanding what that path will look like for you and your organization. Further, this concept of kind of the drivers around artificial intelligence is different. Not everyone has the same needs. A lot of this is going to be based off of specific challenges to your specific business problems, right? Is while there's a lot of things common across an industry, there's also a lot of things that are proprietary to you. There's a lot of things that are going to be differentiators for your specific segment of that business as well, and things that you'll be able to potentially capitalize on to fight competition. And another thing that gets often overlooked is successful AI tends to need to be part of kind of a cultural transformation. And we'll talk about what I mean by this a little more in some of the later slides. But the general idea here is there needs to be kind of a mentality shift within an organization for AI to be successful. You need to be able to move past these kind of legacy ideas of everything being done manually or everything going through the hands of, trusted subject matter experts within your organization. So there needs to be a level of trust around not just your data, but the processes that you're putting in place that are driving this AI. And that tends to require some cultural transformation. And then this kind of last point is that it isn't something that can be just driven from top down or even bottom up. It needs to have a combination where you kind of meet in the middle. And you'll see that, I think, as we get into some of the case studies towards the end of this presentation, that a lot of these organizations really are doing this transformational change in order to support these things. They're trying to step back and look at how they do business in a very different kind of lens there to move through. As a consequence, though, I think you'll find that you tend to see a lot of larger organizations kind of leading the way for this, which may be a little ironic because it's harder for some of those larger organizations to do the kind of wide transformational changes. But it also is a situation where they have the resources to be able to do it, where smaller organizations may struggle with that a little bit. But again, as we get into a little bit of the maturity model, we'll talk about some kind of maybe baby steps to get there. So moving into manufacturing specifically, there's a number of drivers for what's kind of pushing AI in manufacturing. I'd say probably the biggest is just disruption in the marketplace. And these numbers that we're looking at here on the screen are all pre-COVID. And so obviously, since we've had this pandemic's impact, both globally and in our various regions locally, it's had an even greater impact and probably a very different impact in terms of disruption as to what this is specifically referring to. In many cases, this is talking about disruption from new competition moving into your space, maybe higher technology or newer startups that are disrupting a lot of this, or maybe newer changes to things like supply chain and how you go to market. And so this idea of kind of disruption ends up being a little bit of that kind of main driver for this. But there are a few different spins on this as well. And I would say that some of this was amplified also from a COVID perspective, kind of like this first bullet point around workplace safety and health. When we're talking about health, this isn't just a matter of your employees being safe, let's say on a plant floor where they're utilizing equipment. It also has to do just kind of with work-life balance, with, again, the COVID example, being able to maybe work remotely, being able to do kind of a webinar like this as an example, as opposed to in person. And AI is one of the areas where there is some promise in kind of improving some of that, where rudimentary tasks are taken over from some sort of robotic process automation instead of just a person doing these rudimentary type tasks. And so that's another kind of driver in this, is getting more value out of your, I guess, human workforce, right? Is getting them focused on the things where they can have the highest impact and removing a lot of the kind of mediocre tasks from their plate. But again, these are just a handful of kind of the drivers for it, and your drivers will probably vary. But again, where it usually starts is this kind of concept around disruption in your industry. So in terms of this kind of potential of AI in manufacturing, we're not going to go through all of these bullets, but you can certainly take a look at these when you get the kind of the video copy. But there's a number of areas across, I don't know, a couple dozen different studies that have come out in the last few years talking about the impact that technology is having and kind of disrupting this. And so looking at things, everything from cybersecurity aspects of AI for being able to detect things like intrusion detection to more intelligent manufacturing processes to become more efficient, quicker, doing maybe some more just-in-time type manufacturing, improving the engineering side of it, and so on. There's a lot of money behind this as well. So it isn't just a matter of, preventing this disruption. It's a matter of improving kind of the bottom line of a lot of these organizations. So let's talk about a few of these solutions. So many of these you may have heard of, but I'm guessing that a few of these are probably new to you as well. One of the hot ones at the moment is our first one here, and that's kind of digital twins. And we'll talk about this in a case study. This is one of the examples that we'll be going through. But digital twins is an interesting one. And I guess this isn't, again, something that's new, but it's something that has been kind of newly revamped. And so what is a digital twin? It's essentially a digital representation of some sort of physical asset. That may be a plant floor with a graphical representation of the plant floor with, various boxes and icons and so forth that are representing the various tools and machinery that you have. Again, that's not new. That's very common to manufacturing to have that kind of view. What is new is kind of applying the AI on top of it so that you get a more holistic view. And so that AI is able to bridge the gap kind of between maybe some knowledge bases around this equipment. So understanding like maybe when the equipment was last had any sort of maintenance applied to it. It's then also looking at all of the operating parameters, all of the data that is being streamed in from that equipment in real time, and looking at, again, those operating parameters, comparing it to things like the maintenance history, maybe not even the maintenance history, but it might be looking at who is the technician that is currently operating this hardware. It could be looking at a lot of different things, and then it makes decisions on the fly, or at the very least, maybe notifying, let's say, a plant supervisor or something around what is going on. Further, where it branches out beyond that machine is it's trying to look at the processes in a holistic method. Maybe it's looking for inefficiencies as, let's say, a manufacturing process moves from station to station. And again, we'll get into a more specific case study example. But the main thing they kind of understand here from a digital twin perspective is that it is essentially a digital representation of some sort of physical aspect. I believe that the case study that we're talking about is actually elevators in businesses and keeping track of those elevators at a global scale across thousands of office buildings and so forth, and getting that information back and being able to see a lot of that information quickly. But again, we'll get into them. Another is AI-driven robotics, and robotics is absolutely nothing new in manufacturing. It's been going on for quite some time, especially in a lot of larger manufacturing processes. But where this is starting to change is the AI is getting better here, where, again, the robotics can change on the fly. So again, maybe it's adjusting to nuances in the material quality that's going through it. It's some sort of a machinery that's cutting metal as an example, and that metal may be variable in terms of the hardness and so forth. And so the AI is automatically adjusting for that to prolong the longevity of, let's say, your mills and that sort of thing that are actually doing the cutting. So it's adaptive kind of AI applied to robotics. Just this generative design side of it, this is probably one that is not as commonly thought of, but this is using operating information, the data that's coming back from the things that you may be manufacturing out in the field, using that to help then do AI generated design changes for engineering. So it's improvements to the design. It may also be doing AI applied, again, engineering based on kind of multiple simulated scenarios where the AI goes through thousands of permutations of different operating possibilities for a piece of equipment and then provides recommendations back to your engineers to help redesign whatever that product is, whatever that piece of equipment is. And so generative design AI, again, is another area that's growing very, very quickly. Again, a large number of these other ones like predictive maintenance, process automation, some of the quality inspection insurance side of these are far more common things that you're going to see, and they probably tend to be the areas that the AI companies are pushing the most as well, because it's really easy to kind of explain the benefits of this, especially things like a predictive maintenance, because it is so costly when something breaks or goes down. And if we have that ability to kind of predict that that's going to happen and get ahead of it, or maybe even better arm our field technicians so they don't have to go out, do an assessment on why it failed, and then go back to get parts and then come, where they could already be armed with the appropriate parts. That is, a brain dead simple thing to understand in terms of the value that brings. And so predictive maintenance is super, super common here. But I think what I would like you guys to understand as you're thinking about some of these things is these various types of solutions tend to fall into a couple areas. Some of these, like a predictive maintenance, is something that helps your efficiency, which again helps your bottom line and helps your ability to compete. But it tends not to be something that may be unique to you, meaning there's nothing stopping your competition from doing exactly the same thing. Some of these other things around like generative design and so forth are areas that you could capitalize on that give you a competitive benefit over your competition, because it's an augmentation of your existing talents, an augmentation of, let's say, your engineering staff. And then that gives your engineering staff just a little bit more of an edge over what you may be seeing in a competitive landscape. Again, we're not going to necessarily go through all of these. I just wanted to point out a few of them. But another very quickly growing one is this idea of around smart assistants. And these tend to be things like your chatbots and so forth. And there's a very wide variety of the intelligence applied here. Some of them are very rudimentary and simple and just have a knowledge base behind them where they can answer rudimentary questions that are being posed to them. Others are actually being used to initiate work. So it might be a scenario where I'm not just asking a question of my chatbot, but my chatbot is actually initiating maybe a workflow that is going out and doing something. So an area that we might see this in a data analytics perspective is I might ask a chatbot, to show me my financial data for 2019. And it goes out there and it fetches that information, or at least tells me where it is. But the next kind of step of applying intelligence to that would be I could ask that chatbot to go gather that information and maybe a couple other data sets and build me a custom purpose-built data set for me that I can then apply something like Power BI on top of, where it is programmatically actually building this data set and fetching it from my data catalog to get the various components. And it's a way, again, of applying AI to some of these self-service areas. And so there's some very cool things that are occurring there. But in a lot of cases, that is more on the custom development side of things because there are not necessarily off-the-shelf products that are doing that right now. So let's talk about some of the challenges here. And there are a lot of challenges. I don't want this to come off as it's all sunshine and roses and all you need to do is apply a few of these AI techniques and your business will be screaming. It really is not the case. There are some major issues. And these charts right here are kind of showing the difference between the manufacturing as a total industry versus the general industry. So in general, data quality tends to be better across manufacturing. Manufacturing is known for a while that data has some importance to it, and so they have put effort into ensuring data quality across their organizations. And so data quality doesn't tend to be as big of an issue with manufacturing, but it continues to be an issue here. Another is the cost side of this. Implementing AI can be very expensive, as I mentioned, that a lot of these things, especially when we get into the things that are differentiators, they tend to be things you can't just purchase off the shelf. They are things that you are ending up having to build yourself or contracting with a consulting firm or something similar to build these out for you. And that gets very, very expensive quickly. And so I'd say it's imperative to make sure that you are chasing after something that is feasible and something that is going to have a good ROI to it. But many of these solutions do have a very high ROI if you can be successful with implementing it. So again, just kind of looking through a few of these. Another area, just some that are a little bit higher from a manufacturing perspective, partly that is C-level commitment. A lot of manufacturing organizations, while they are embracing technology, they do tend to be lagging behind the industry as a whole in terms of their kind of commitment to some of these areas. They'll, again, we're speaking generally here, but they will go after some of the tried and true types of AI, like maybe the predictive maintenance, but they might be ignoring some of the others. And again, that's where I'm getting into that some of those other things, again, the more nuanced things, the more specific things tend to be the ones that have the potentially higher ROI and have the potential to disrupt an industry far more. And so a lot of times the organizations that are investing in it are the ones that are going to kind of, zoom up to the top. But again, it's going to be a unique kind of journey for everyone. And I'd be very interested to kind of hear some feedback from you guys at the end of this presentation as to like what sort of challenges are you maybe seeing internally if you attempted to either float an AI type solution within your organization or if you're already in the midst of implementing some of these. So one of the things that we have going for us is kind of this AI skill growth across various industries. Right now, not surprisingly, and this is a little bit old, it's based on 2015, 16, and 17 data, but you can see the growth rate of AI skills within software and IT. And this is kind of a no-brainer. Of course, that's where it's going to hit first because it is a software and IT-driven technology set. But you can also see that manufacturing from just a general industry perspective is right up there. The only industry that is really ahead of it in terms of just kind of your standard industries that are not necessarily technology based is finance. And finance is definitely jumping in pretty hard with applying AI. A lot of areas there, everything from the kind of security aspects in order to kind of protect from data breaches and that sort of thing to just understanding again patterns in their financial data. Could be fraud detection, could be a lot of different things, but they're embracing it at a much higher rate than most of the industries. But again, manufacturing is embracing AI and it continues to grow kind of with double digits year over year. So with that acceptance though of AI does kind of bring with it some maturity models. And I think understanding a maturity model is important if you are going to be successful with this, because it's understanding that you need to maybe walk before you run. And again, we're not going to go through all of these at all, but want you to definitely understand that there is a pretty well-defined growth pattern around AI that is emerging from the industry, where there is some foundational things that start it, and then it grows into a far more mature thing. But the other aspect of this that I'd like to point out is the bottom line here, this cultural shift. Another aspect of kind of our data culture as it's moving forward is not just the cultural side of it. That's where it might start, but there is definitely an ethical side to this. Companies like Facebook and others have gotten a lot of criticism for the types of data, the personal data that they may be collecting around, their, users essentially. Well, those same kind of ethical questions fall into any data that you may be collecting, whether it's use data of your customers or if it's maybe customer demographic information that is being used to drive behavioral analytics around AI. So there's definitely some cultural thoughts here that lead into these ethical kind of thoughts, and just don't want to lose sight of that. And we're not going to, again, go into a lot of detail of that, but just keep in mind that it is not just a matter of we go out and throw these things out there. There's some thought that needs to go into it. And that is part of maturing as well. So let's walk through a few of these. So that foundational, there's a handful of characteristics here. But the main thing is this is where the interest is peaked. You're going out and trying to understand how AI may be being used in your industry. This webinar is a perfect example of that. This is meant to kind of educate people on the foundational. Again, this is a very introductory webinar, so I'm not focusing any of this on someone that's higher in the maturity kind of chain. And so this fits a very broad audience here again, those that are kind of exploring what AI can bring. Where their focus tends to be is on very fast and quick outcomes, and usually utilizing established platforms. So these are off-the-shelf type of AIs. Maybe I go and purchase a chatbot from, or I'm using a chatbot framework from, let's say, Microsoft or something along those lines to implement some AI in my organization. It doesn't tend to be areas where the organization has already started investing maybe in their own data scientists and they are writing proprietary algorithms for their business. Again, it's a very, well, as the name suggests, a very foundational entry into AI. And this is where most organizations are. Their approaching step, this is now where the cultural changes around AI are well underway at this point. They're starting to implement them, and AI is actively being used to streamline and drive new processes. From kind of a digital transformation perspective, this is also where an organization has their assets digitized. All of those assets are digitized. So from that kind of a transformation perspective, they're no longer, maybe just using paper invoices again. And it's kind of a silly example, but it's an easy example to kind of visualize. All of that is resulting in some sort of digitized asset. But it goes beyond that. There's a digital maybe copy of all of their assets, whether they're physical hardware assets or not. And that kind of goes into a digital twins type of area. And these organizations tend to be investing heavily around the data aspect of it. And so there's a few things pointed out here, like the accountability, governance, monitoring, and that orchestration. Again, this is where things like that governance really come into its own in an organization, and that is part of that cultural shift. Our next one is this aspirational. So the focus here has been shifted to more of how do we utilize AI for competitive disruption. And now we have moved from kind of off the shelf into full-blown kind of custom AI solutions for the organization. The previous kind of maturity step was maybe flirting with some of that, as they were starting to do some of the more advanced experiments. But in this step, we've fully adopted that kind of mentality. And this is also, as I kind of pointed out, where that internal talent is now being acquired. Again, could be from a data science perspective, it could be just general artificial intelligence technology specialists are now becoming in-house. So this doesn't mean you're not relying on outside help any longer, but your primary driver for this is some sort of internal organization. And we see something very similar on the data analytics side for this. Data analytics starts kind of from this IT-driven reporting, and then it kind of moves through a maturity where you start going into maybe self-service. Well, the equivalent here is where I no longer have this being IT specific driven, but I may have an actual organization, a center of excellence within my organization that is focused on data analytics. Well, again, similarly here, I have a similar organization focused on AI and machine learning and advanced analytics, I guess is another way of putting it. So our final kind of step here is the mature step. We've completed our cultural shift. We've now have a little bit of a different focus. It isn't so much on just what we can do, but it's also that what should we be doing with AI? I think this is kind of an important question for a lot of people to go into, and I'm not specifically referring to maybe some of the cultural, or I mean, maybe not cultural, but ethical issues around this, as in should we be doing this because is it the right thing to do? It's more along the lines of should we be doing this because does it actually give us a real impact into our business? Is this AI benefiting us in the way that we thought it would be? And so it kind of feeds into that second bullet at the bottom, where it says continued evaluation of our AI chain, to make sure that it's suitable and that it continues to evolve. Let's jump into some examples. So our first example is from Bosch. I'm not familiar with Bosch. They're a German manufacturing company. They build a lot of different things, but tools and that sort of thing is their specialty. They were specifically looking to use artificial intelligence to improve their quality testing. And they implemented some optical cognitive systems using deep learning that essentially looked at the resulting parts and so forth that were coming through their chain and determined the quality on it. The main impact that they have here is that they were able to integrate this fully into the existing manufacturing and assembling process so that it's not a separate QA step where it has to be separated. It is fully integrated into their existing area, and they were able to eliminate some of those separate testing areas. The other major thing that they were able to do here is to increase just the coverage of that testing, where previously they were only testing a handful of items that were picked kind of at random as they were going through. After this was implemented, they had 100% coverage of every single part that was going through. And you can see some of the stats here. They had a 45% reduction in the amount of time that was needed for this sort of quality inspection. It resulted in a $1.3 million savings. And there's now a 0% escape rate. They have no parts that are escaping that are defects. They are getting caught by the system. All of them are. And in addition to that, this last kind of stat, less than 0.5% are actually false alarms. Our next example is ThyssenKrupp. They are a manufacturer primarily of elevator systems. They are using a mixed reality type of scenario where they're using things like Microsoft's HoloLens to enable their remote staff, their actual field engineers, to have real-time interactions back with the office to help improve some of the maintenance there, so they can interact with the people that are in the field, and they can look up things like manuals and all of that sort of stuff on the fly in a kind of an augmented reality way, and they have AI applied to that. And again, you can see some of the things that they have. There's more than a mixed reality solution, though, behind this. There's also a digital twin solution, and you can kind of see that represented in the diagram in the back, where they have a digital twin of all of their field engine or elevators that they're monitoring. They're monitoring over 12 million elevators globally, and those elevators are pushing more than 1 billion people daily up and down these buildings. And they have a digital representation of it that's showing them everything from the load to all of the various operating statistics of that is then feeding into the data that is used by their field and service engineers to improve their efficiencies. So from that maintenance perspective, and that's what this is ultimately about, but it's a mixture of multiple AI technologies, but it's ultimately about this predictive maintenance and saving on maintenance. So they saved 15% of their cost, and they improved their availability hours of their elevators globally by 95 million availability hours over that. And that's across 12 million elevators with all those billion plus people that are being moved daily. So the scale of this is just, immense when you come to think about it. And this particular example is one of Microsoft's favorite ones to point out, because the ThyssenKrupp is using a complete suite of Azure tools to perform all of these various AI tasks that they're doing. Where in our previous example with Bosch and our next example, they are not necessarily wholly in that kind of Microsoft space. They're using a mixture of technologies. And that's probably the most common thing you're going to see, is not a holistic, I'm 100% on a Microsoft platform, but it's a mixture of things.
Okay.
Our next example is GE, and this is another AI-enabled digital twins effort, but this one is specifically around digital twins, where the digital twins was there to augment predictive maintenance. This is applying digital twins to General Electric's power generation plants, is what it was specifically. By having a digital replica of these physical aspects, they were able to kind of display that real-time status of these physical things, to collect all of the information around the sensors in one platform that showed all of these, where, again, it tends to, these representations of these physical assets in the past tend to be a little more myopic, and these tend to be broader. And through this, they were able to reduce some startup time. And where startup time comes here is they were specifically applying these digital twins as they were rolling out new power plants. And by doing that and getting this holistic view of as all of these pieces of machinery and stuff were coming up, they were able to be more efficient in the startup time of that new plant and reduced it by 50%. In addition, they increased their efficiency of the operating. This is through some of the predictive maintenance stuff that was applied there, but the 5 million additional units of power essentially were able to be generated every year, and they're saving $150 million a year from unplanned maintenance and so forth. So again, the reason why we kind of look at some of these examples and bring them up is just to show maybe some of the ways that they are being applied in the industry as a whole. And most of these examples, again, are very large organizations. But the general idea I want you to kind of get across here is they aren't just adopting a single AI technology. Every one of these is using a mixture of technologies to ultimately drive this outcome. It may start small. It may start with an experiment, let's say with Bosch, where we are taking just maybe it's x-rays or photos of parts and so forth as they're moving through a manufacturing line. And we are marking that data as to which are bad, which are good, and applying a machine learning algorithm to learn those patterns. We might start there just so we can have a quick identification. But that's not where it ends. Where it ends is actually the operationalizing of those algorithms, so that our machinery can automatically act on it. It automatically kicks out the bad part, or it automatically maybe is adjusting something downstream because it sees a pattern of quality that is degrading as it goes through, and we need to make some adjustments. Those are all things that organizations are largely doing manually today. They're largely manually inspecting, they're largely manually adjusting the kind of the parameters around their machinery and so forth. And it just is not nearly as efficient as some of these automated systems. It's also important to kind of understand is these automated systems, they don't sleep, they don't change shifts, they don't do any of that. They just run and run and run. So let's talk about some AI and you. So specifically, what are some considerations if you're approaching digital transformation in your org? And these are all questions that, in general, you should be asking yourself or asking in your organization. Comes back to that very first thing I talked about, and that's kind of the data quality. But it isn't just about the quality of data, it's are you collecting the relevant data? So let's say that you decide that a predictive maintenance solution would absolutely benefit your organization. But then you sit down and you look at the data that is needed to support that system. And are you collecting the right data? Do you have accurate information that could lead to developing those patterns to predict those various fail scenarios? Again, those are the type of questions you need to be asking yourself before you jump into this. Because just because AI can do something, theoretically, doesn't mean that it's going to be able to do it with your data. And it doesn't mean that you're collecting the right data. And this is also where that kind of cultural shift comes in. It's really hard to do some of these things if your organization does not see data as an asset, because you're going to need to invest in the widespread collection of that data and the storage of that data, the curation of that data, the governance of that data. There's needs to be that kind of shift around that sort of thing where it isn't that data is just a byproduct of what I do. Data has gold in it, and if I mine that gold, it can make a difference for my organization. That does lead into this next question. What are the cultural challenges that I have? So some of the examples we didn't really get into, but I know that Bosch was one of the examples where they had some early issues around some cultural challenges where the various teams in the manufacturing process, they were really holding on tight to the steps and the processes they took to identify some of these quality, and they saw it as theirs. They owned it. They didn't see it as like collectively, this is something that belongs to Bosch. They saw it as this belongs to my group and I don't want to share. And so they had to break down some of those barriers and kind of convince their internal employees that this was for the kind of the greater good of the organization. A lot of organizations are siloed like that. So that's just an example of maybe some cultural changes that need to take place, is to maybe break down some of those silos. Again, we won't go through all of these, but again, are you empowering your employees to make data-driven decisions? Are you actually giving them the tools and the data that they need to make these decisions? Where are the most inefficient areas in my organization where I can have these improvements? That's usually the low-hanging fruit, is find some area that you're currently very inefficient and see if there's just some minor changes I can do. Think of it this way. I'm not always implementing something like an AI or machine learning to get 100% improvement in my processes. In fact, I would say that that's generally impossible and not the case. But if I can get a 5% improvement, does it pay for itself? It may or may not, but that's kind of the questions you need to kind of ask. And then ultimately, these kind of bottom two are probably the biggest ones, is can AI actually solve my problems? Don't look at this as I need to have AI because that's what the industry buzz is. Your organization may not be ready for it. Not only may your organization not be ready for it, But AI may not be ready for your organization. Maybe your specific problems are not things that are well suited to the current kind of algorithms that are out there and being developed. That's very, very possible. And then ultimately, this last one, do you have any sort of definition around what your business outcomes are needing to be? Where do you actually want to go with this? Because this isn't something that you typically just play with and it's just a cool technology. I ultimately need to turn this into some sort of investment that is going to return for me. Brings us to the end. So not sure you guys have some questions queued up for me. Let me stop presenting here. I'll go to chat. And any questions you might have, feel free to pop them in. We're definitely happy to assist in any way that we can. Don't be shy.
Hello, thank you very much. Can you hear me?
Yes, I can.
Okay, perfect. So thank you very much for your presentation. It was very interesting and with a lot of different examples. You were talking about all the tools, infrastructures the different examples and companies use. I'm interested a lot of the cloud and on Microsoft Azure. So can you tell me some tips or maybe whether you think that it's a good way to have all our infrastructure in the cloud for a specific tool? And what do you think about it in a specific cloud company? Sorry.
Yeah, sure. Covenant, my organization primarily focuses on Azure-based implementations. And there's a number of things in Azure that are fairly unique to it, like some of the Azure cognitive services. And if you're not familiar with the cognitive services, or those are the things like the image recognition using AI for the vision recognition, for the various sound recognition, text, that sort of thing. And those are kind of packaged solutions that come with Azure. But further, Azure just as a platform has a wide number of things that are used to kind of support these systems. Everything from their IoT platform, because remember, a lot of this data is going to be streamed in from sensors that's coming from machinery and so forth. And they have an incredibly strong IoT infrastructure. I believe just this week there was a study that was put out by Gartner talking about how they have pulled ahead of their competition in the cloud in terms of like that IoT infrastructure. And so they're now currently kind of the leader in that space. But I do want to caution that this is not about Microsoft. You can do this in a lot of different places. AWS's cloud from Amazon, as an example, is an awesome cloud. It really, really is. And most of these technologies have a mirrored version over there as well. So while you have packaged solutions in Azure, things like Azure Digital Twins as an example for implementing this, or Azure machine learning for building out some of these algorithms and the pipelines behind it, much of this stuff can be built elsewhere. But in terms of kind of your specific question as to whether it's a good idea to do this and move some of this infrastructure in the cloud, I don't think that it's just a good idea. I think it really is the only way to achieve some of these things at scale. The amount of investment that you would have to do to build out a local data center to support some of these solutions, especially some of the case study solutions we talked about, like the ThyssenKrupp one, where they're monitoring over 1 billion elevator rides a day globally. It is cost prohibitive to be able to do that in your own kind of infrastructure. The amount of compute that you would need to have sitting idle to support some of these machine learning algorithms and so forth too would become cost prohibitive very, very quickly. And so the promise that the cloud brings, again, no matter which cloud it is that we're talking about, is that ability to kind of adjust and scale on the fly. So I can bring the compute to my problem when I need it. I scale up for that instance and then I tear it right back down. And so I'm only paying for that consumption. It is really, really difficult to do that anywhere but the cloud. And so again, I wouldn't just say that it's a good idea. I think it's probably the only one that makes sense at this point. So there was a question in chat kind of around AI use in medical diagnostics. That is again a very huge growing area, and it's not necessarily an area that we covered in this kind of presentation since we were focused more on the manufacturing side. Although of course any equipment that is being used on the medical side is being manufactured at some point, and AI could be built into those tools. But the main areas that you're seeing it is a couple. One is looking at kind of wide variety of um, medical kind of sensor data that's coming in, everything from blood pressure readings for your patients to results of various testing and that sort of thing, and looking for patterns across that for diagnosis of diseases and so forth. That's the main area that you're seeing it is around that. But you also are starting to see it in areas where AI is kind of protecting or providing a second set of eyes. So I used a very brief example earlier of like x-rays in a manufacturing process. Well, we obviously use x-rays in a medical scenario as well and other various scans. And a lot of times, especially on something like an MRI and those things, you're generating potentially hundreds, if not thousands of images that a doctor or a medical professional needs to go through. If those images can be passed through an AI first to look for anomalies, for starters, that kind of reduces the footprint that needs to be gone through for that medical professional. But it also may identify patterns and things that they are just not readily able to see because of just the scale of what we're talking about. But yeah, AI is absolutely being used in the medical industry. And it's a very fast growing one. But at the same time, that medical industry, as I'm sure you guys have heard, I mean, they are having a lot of data issues because of privacy concerns and things like that. But it's also this kind of digital representation of their patients from those digital medical records. While they're scrambling to move there as quickly as they can, they're also lagging behind from just a general industry kind of perspective. They're behind manufacturing. They're behind a lot of organizations in digitizing all of that data. And they're doing it very rapidly and they're probably moving faster than most of the other industries, but they haven't caught up yet. And that's another problem for applying AI in a lot of these spaces is, say it, one more time, data is the key to this. And so if you don't have good data, you don't have good AI. All right, one more question. To what extent can AI impact employment and manufacturing in the next 10 years? What are the jobs that will remain in manufacturing and what are those that will be gone? Well, I don't know. This is hard to say. I mean, there's definitely a lot of AI that is driving automation in manufacturing, but we've seen that for multiple decades now, especially with the robotics and so forth. And in general, it hasn't, eliminated any need for humans at all in any of these processes, but it does shift maybe where their responsibilities lie. And so I would say that probably the growth areas that you're going to see is in the areas of the individuals that are maintaining a lot of these systems and are maintaining these processes. But in the end, AI is not being targeted to replace humans in any of these processes. The number one area where it's being targeted is to augment the humans and to make their jobs, well, quite frankly, more satisfying because it eliminates a lot of the menial tasks that they may be having to do and it lets them focus on the areas that they are best at. It lets them apply the areas where they have the most impact. And so, how is that going to change? Well, one, I think that manufacturing, if it continues to go down this road, is going to have to become more tech savvy. It's not just about pulling a lever any longer on the shop floor. But again, it hasn't been about that for a long time in many manufacturing organizations, but that'll continue to evolve. I don't know that it's really going to be as widespread of a replacement, though, as people think it is. It kind of goes back to that original statement of what isn't AI. We don't have AI that is like you see in a sci-fi movie or anything yet. Maybe we will someday. But most AI, while it is very complicated and very intelligent in what it's doing, it is nowhere near like a human. It's very, very myopic. It's good at one thing. It's good at identifying this single pattern. Well, applying that from a wider perspective again is the job that we fill for it. And I don't see that going away in the next 10 years. It just won't happen. Anyhow, we are at the end of our time. I hope you guys learned something from this. Hope you guys got something. If you do have any further questions, I'm sure Michelle will be sending out not just the link to this presentation and so forth, but ways that you can contact us if you have any further questions. And we can definitely go through and help you in any way possible. I appreciate you guys and thank you for coming.